say, if we look at the pyramid, right, with a square base, okay. Find the volume. Of a pyramid with square base. So let's look at the pyramid. So for the pyramid, I need to know two things. I need to know the length of the base, and I need to know the height. Length of the base. And I need to know the height. So I guess I need two numbers. At least to my picture, height looks bigger, so it's 7 and 5. Feet, inches, yards. I'm not concerned about the units. If you want, go ahead and put your units. We're going to write your units. Okay, so we get that. So now let's see how we're going to address the situation here. Of course, we can put it sideways on the side horizontally, and we'll be able to do that too. But what I will do is I'll keep it vertical. So I'll do, eventually we'll start slices y-axis. I want to do it vertically because I guess I want to see how integral with dy is going to look. Okay, so let's have a look. So I'm going to put that pyramid vertically. Okay, so if I put it vertically, it's going to look something like this. Height 7, and from here to here it's 5, so it's 2.5 here, right? What I'm assuming is that my pyramid kind of looks something like this. Do you see what the way I put the pyramid? I kind of try to outline in green how I put the pyramid and how I put the x, y axis through it. Okay. So if that's good, then we have again x axis, and we have somewhere here y axis. And now our slices. Okay, so let's have our slices. So we start slicing it perpendicular to axis, right? So our slices is going to look something like this. Difficult to visualize them, but we'll try. You see our slices. Okay. Do we see slices? Slices. Okay. Then essentially, again, using shortcut, we know what the volume is going to be. Volume is going to be integral, start, finish, area of cross section, dy. Okay. So we know where we start. We know we start at the bottom, y equals to 0. We know where we finish at y equals to 7, right? So that's where we finish, and we start at the bottom. So I'm going to mark in the red starting and finishing position. So we start at y equals to 0, and we finish at y equals to 7. And we want to do dy because that's what we indicate. Right? So the only thing which is missing is area of cross section. So that's the only thing which is we need to calculate, the area of cross section. The area of cross section. And that is basically what we do. We look at our slice. So basically look at our slice. On top we see a square. So area of cross section is going to be length squared, because area of square is equals to length squared. Okay. Now let's look at one such cross section on our picture, and I will try to use, I guess, black. So I'm going to mark it in black, so hopefully we'll be able to see it. Okay. So it's right here, and you see that's the length, right? That's the length. That's the length. So length comes from a projection, and you see you can project it on x-axis because it's perpendicular to y-axis, but you can project it on x-axis, right? And it will be between these 2 points. So if you like, I will. So that is picture, right? I do two-dimensional projection on XY plane, and then that's the length. That's the length. And it's the same length, right? So it's from here to here. That's the length we're talking about. And if this point has coordinates x, I, y, I, then the length can be expressed in terms, because it's horizontal, it can be expressed in terms of x, because x is horizontal. So length equals 2xi. So we conclude from here the area of cross section is going to be 2x squared. So that was the only missing piece in our integral. Okay, so let's copy what we've got. We're going to put volume equals integral 0 to 7, y equals to 0, y equals to 7, 2x squared dy. We basically set up our integral, and again, that's area of cross section. Dy because we sliced y-axis. Y equals to 0, that's where we start. Y equals to 7, that's where we finish. To put 2x in parentheses, right? Because now I have to put length squared, and length is 2x, so I should have parentheses here. So that's a good comment. Sorry. Okay. Because we have a square base, a square cross section, that's area, so length squared, length is 2x, and so we're going to do 2x squared. I guess I have to be careful with parentheses. Okay, so don't forget about parentheses. So I guess one more time, volume equals y equals to 0, y equals to 7, 2x squared dy. Don't forget that's the indicator, right? It sees that everything should be in terms of y. So we need to express that x in terms of y. So let's look at the picture one more time. Okay. So that x is here. So this point has coordinates x and y. On the bottom, we had, let's scroll me back, 2.5. On top, we have 7. So 2.5 and 7. So now if we look at that line, y-intercept 7. Slope run is 2.5. Rise is -7. So -7 divided by 2.5. So we have y equals -7 over 2.5 x plus 7. Okay. And what we want to do here, we want to express x in terms of y. So we're going to be solving this one for x. So solve for x. So we're going to solve it for x. So we have y minus 7 equals -7 over 2.5x. So 2.5 y minus 2.5 times 7 equals to -7x. So x equals 2.5 divided by 7 with minus y plus 2.5. So that expression we're going to substitute for right here. Okay. And then we should be able to finish it, right?